Alrighty, well, why don't we get started? So thank you all for joining us at the Tufts Research and Data Symposium for Food and Nutrition. We're so excited to have this workshop on effective data visuals with Dr. Tania Alarcon-Falconi. Dr. Falconi is not only a dear friend and colleague, but she has been part of the Tufts community for some time. She's currently a senior scientist in the Advanced Analytics Division at Environmental Health and Engineering, Inc., and an adjunct assistant professor at the Friedman School of Nutrition Science and Policy at Tufts. Tania has extensive experience in analysis and visualization of time reference data. Her current projects include time series analysis of energy consumption in hospitals, assessment of the impacts of renewable fuels on greenhouse gases, air quality, and public health, and collection analysis and visualization of COVID-19 data for schools in the Northeast. So excited to have her here today. And with that, I'm going to turn it over to Tania and let her run through what she has in store.
Thank you. Hi, everyone. Welcome to this session. I see some familiar names that we've met before. Excited to see you here. And if I haven't, I look forward to meeting you in the future and hearing your questions and your comments throughout this session. So as Ryan said, I've been involved extensively. I've been part of Tufts University for quite some years, and I'm also a senior scientist in environmental health and engineering. I used to teach actually full-time at Tufts. And if you've taken a class with me, you know that I really like to have interactive sessions. I really don't like to just be the one who talks. Now, this is a little bit different because it's a larger group and there are a lot of us. So what I'm going to ask of you today is if you consider this presentation not as a traditional conference presentation where you ask your questions or have your comments at the end. I would actually prefer if you ask your questions as the session is coming along. Now, to avoid there being a lot of problems with people unmuting their mics, what I'm going to ask for you to do is to put your questions in the chat. And we're going to have Jesse is going to be filtering your questions and let me know what your questions are as soon as you come in. So please post questions and comments in the chat. I may ask some feedback from you as I go through these slides. So I would welcome also your comments about the visuals that I'm going to see. So I would like to make this as interactive as possible with Zoom. And of course, we'll have some Q&A, more official Q&A at the end, but throughout the session, please ask your questions. So let me share. And just a quick reminder for anyone that, okay, so quick reminder for anyone who just joined, I would really appreciate it if you ask questions throughout the session in the chat and I'll be answering them as I go along. Ryan, I cannot share. It says that host has disabled participant sharing.
Actually, Jesse, would you be able to share? There we go. Great. Should be all set now. Sorry about that.
Perfect. Okay, so you hopefully should be able to see my presentation. Is that good? Can you see this, Ryan?
All set.
Great, perfect. Okay, so the title of this was called Effective Data Visualizations, but what I'm actually going to talk to you about is about E-cubed of visualizations. So visualizations that are effective and that have the right emphasis and that are based on good, solid foundation of evidence. So the objectives, we're just going to quickly discuss key concepts of data visualization. I am going to present some figures for us to graphically evaluate them together. So that's where I would like your input. And then I'm going to list just best practices. Just quick logistics, Ryan, when is this session supposed to end?
We're going to go until 6 o'clock.
Perfect.
Yeah, 6 o'clock.
Great. Okay. So we encounter data visualization throughout our careers and throughout our lives. We can see it in newspaper articles, such as the New York Times, for example, this figure. We can see it in reports. We can see visualizations in reports from, for example, the United Nations Data on Nutrition, and of course in scientific publications, which is this figure on the right. I'm going to be talking about each one of these figures a little bit more in the following slides, but for now, just an idea that we're constantly being exposed to different visualizations. So It is said that a picture is worth 1,000 words, but this can only be true if there's an advantage of using a graph versus a table of a text. So we need to make sure that we're gaining some sort of benefit by putting this effort into creating this graph or table. Quick question. I just got a message that said there's someone in the waiting room. Do I need to let those people in?
Oh, we can.
Great.
I'll come in. Yeah.
Thank you very much. Okay. So for a picture to be worth 1,000 words, we also need to make sure that we have good quality data, good quality of analysis, and good quality of the visualization itself. I'm not going to talk about data analysis in this presentation at all. We're going to focus on the visualization, but I'll touch a little bit on the data because we cannot look at visuals without thinking of the underlying data. But we're going to focus on visualization, not thinking of the potential analysis or the potential like analysis or assessment that you did to your records before they became visuals. Let's start with those key concepts that I mentioned, that E cubed, right? We talk about evidence, emphasis, and efficiency. What do I mean by evidence, emphasis, or efficiency? First of all, evidence is based on the underlying data that you're presenting in your figures. So the questions that you can ask when you see a visual is what data are presented in the graph? Do this data descriptions match the information that the graph conveys? Where you're looking at how sound are the records that are being presented to us. When it comes to emphasis, it's more of a question of why and who. Who is this visualization done for? Is the target audience the general public, as you would be, for example, through a newspaper article or through a report? Is the general audience a group of people who are attending a conference presentation? Is it a scientific audience, perhaps, because for a paper? So because all of those, depending on the target audience, the emphasis on my figures is going to be different. The emphasis on colors, the emphasis on shapes, the emphasis on text, everything is going to be different. And through this process, I need to think about, why is this visualization needed? What is it that I'm trying to show? Why do I need to present this type of information in terms of a figure? And the last one is efficiency. It's more what you would think about like, how do I actually build this visualization? Do I need a line chart? Do I need a graph, bar chart? Do I need a box plot? Like, what do I actually need out of this? Do I need a pie chart? Do I have good visual properties in terms of the type of colors? Like, if I'm considering a wider audience, am I thinking about things such as like color perception and the fact, for example, that the color red may have some connotations, and perhaps that there are colorblind people who may need to also access our visualizations? Like, am I thinking of those good visual properties? So it's good to consider, the what information is shown in terms of evidence, the who and why, which is emphasis. Who's going to observe this? Why is this needed? And then efficiency in terms of how am I building this graph? And I would like you to think of this E cube as we go and take a look at some figures. So this is the first place where I would like to start to get your input in the chat. So please, I will welcome you to start to make comments and ask questions in the chat. So this is a figure that was part of the New York Times it was a news article titled, "Is Sushi Healthy? What About Granola? Where Americans and Nutritionists Disagree." Now, this is a figure that when it came out, which is, I don't remember when it was, 2016, the first time that I showed this, at the time, a lot of people would recognize this figure immediately because it was very easy to remember this type of figure. And one of the reasons why it's easy to remember this type of figure is because of the icons that you see, right? And the message itself. What is healthy? What is unhealthy? How do I interact with this figure? So as an observer, if I start to think of, why was this graph needed? Why did, for example, the New York Times decide to create this figure? One of the reasons could be to present some of the information that they're going to talk about in the story. For example, where Americans and nutritionists disagree, as the title says. Are there some foods, for example, granola, where Americans may think that is healthier, as represented by the granola being farther on this X scale, right? So approximately 80% of people are thinking that granola is healthy, but what about nutritionists? Do nutritionists think that this is healthy? So you start to get some information, which, whoever created this figure may want to present the information from that title. But the other reason, right, is to get readers to actually engage with the story. If you see this figure on, say, any social media platform, you may be like, oh, I'm interested in reading a story, and you may click on this and it may take you on the site. So the fact that they're using this bright like figures and this like catchy titles also brings you to engage, it leads you to engage with that figure. So that's where you can start to think about that emphasis, right? Like, who are the target audience? Why would someone decide to start to use these icons? Is this a figure that you would put in a paper? Like if this was a scientific paper? Definitely not, because it's not something, unless you're creating like a graphical abstract, it's not something that is traditionally considered the type of figure you would publish in a paper. Now, as you take a look at this, I would encourage you to add your comments. Like, how do you feel about this figure? Do you feel that this figure portrays the information that you would want to see? Start to ask questions of, how do we define healthy? Like if you engage with this figure, if you think, let's start with the granola example, like how do you define healthy in terms of like nutrition, right? Nutrition data science. Is it just the fact that you say granola, period? Is that enough for you to determine what's healthy? But then you can also start to engage with this graph based on those other E-cubed properties. For example, evidence. What is shown here? What is the underlying data that are being shown in this graph? So what is considered healthy? Is this based on portion sizes, right? It's not the same, for example, to consider a whole gallon of milk. If I say a cup of milk versus a whole gallon of milk, what that is considered healthy is going to vary. Is it a whole cup of milk? What about frequency? How often are we consuming this? And quantities of consumption of this. So the question of like, what is being considered quote unquote healthy, what is being defined as healthy is going to be very important as you start to engage with this figure. The other thing is to consider who are being defined as all Americans and who are being defined as nutritionists. And this is information that is likely going to be included in the body of the report or of the newspaper article, I would hope. But it's something that you should ask yourself as a reader and as a consumer of information. Like, is it really all Americans that say this? This is likely more of a sample size, right? Like who participated in the survey? Who did the survey? Where was the survey given? Was it primarily to say like people in universities, like higher ed, students in higher ed? Or was it just truly general population and they tried to get people from across the US? Was the sample size 100 people or was the sample size 10,000 people? So you start to get a sense of like, how accurate do you believe that this could be? So in terms of visual properties, oftentimes there's not a truly like good or bad. Is this a good figure? Is this a terrible figure? Really difficult to know. I think this figure has some merits based on what it was intended to do, which is attract a general audience to click on a story, read your story, engage with your story. If you want to get more information about what is truly healthy, what about portion sizes? Like, can I get more information? So you as a consumer of this information, you can start to ask more questions where this graph starts to fall apart. And you can start to notice things like, okay, what is a kind bar versus a granola bar? Like, what's the difference between those two? Why do I need to include a brand name in some of these, but not in others? What about Slim Fast? What about portion sizes? Is it truly a whole gallon of milk? So you start to engage and to get a sense of like some of the shortfalls of this graph. Okay. If there are no questions thus far, I'm going to continue on to the next graph. But the idea is of thinking of what is healthy and, is this healthy or not? Unknown, hard to say. What is this based on? What portion size do I have? But thinking of evidence, emphasis, and efficiency, emphasis, if the goal of this was to get people to click on the story, great job. Let's continue. Thinking of ways Jessie, did you have?
Yeah, we just have one comment in the chat from Echo saying that she's surprised that 25% of the nutritionists think pizza is healthy.
Right. So, and that's where if you have, what was asked in the survey? How were these questions asked? Was it a serving of pizza for an adult size based on what recommendations? What type of pizza makes a huge difference? Is a fully loaded like pizza with tons of like cheese and meat and fat and maybe, I don't know, French fries on top or something? That may not be as healthy. But then what if you have a different, like a standard, just maybe like pizza with some veggies? So it may be, how you ask the question and what comes into people's minds as they engage with those questions becomes also extremely important. So that's why you have whole classes in college or even in school about, or if you want to engage in some like online courses on survey design, how you ask those questions becomes very, very important. One thing on how to read this type of graphs is when you have two scales, one on the Y and one of the X, anything that's on the diagonal means that a nutritionist and quote unquote all Americans, or the sample size of the survey, agree. So chocolate chip cookies were both considered to be quite low. Really high up, apples, both groups consider it to be quite healthy. Anything that deviates from this diagonal is going to be that one group consider it healthy than another. For example, granola, coconut oil, frozen yogurt, granola bars. Americans tend to consider this to be healthier than nutritionists tend to consider this healthy, right? So quote unquote, all Americans are thinking that these type of foods, 70 or 80% of people think that these foods are healthy versus only, between 35 and 55 or nutritionists. One thing I would say that is quite difficult, for example, when you have logos that are this big, is that granola could range anywhere from say about 43% or so, all the way up to about 52% is really high. Like, where do I take this? Do I take the centroid of this image? And so in a figure like this, when you don't have to be too detailed and too specific, it's not a big problem. If you're presenting this in a journal, the journal would want to know, like, is this the centroid or where is this falling? Like, what is the range of, or the width of this? Is that actually like an error bar or something? So it starts to become trickier if you want to use this type of information in a journal. But yeah, some of these things are surprising. So in terms of observing in this type of graphs, differences between foods, for example, it's quite easy to see in this figure that coconut oil is considered healthier by Americans than butter is. But it's considered about the same by nutritionists, simply because it's on the same line, right? If I take 40%, same line, for nutritionists, same line. For Americans, about 75% compared to about 35% for butter. So really clear distinction that I can see based on where these two icons are located on this graph. If I want to compare by quantity, for example, whole milk versus popcorn, if I'm thinking of the quantity of the volume, like the granola bar versus like the 3D shape, the 3D shape of the butter versus the 3D shape of the coconut. And I'm starting to think of 3D shapes. 3D shapes are a lot harder to compare. Like if I wanted to think of what is the volume of butter that I would need to consume to be healthy versus the volume of coconut oil that I would need to consume, it's much harder to see. So as we're thinking of visual properties, what is easy to distinguish, really easy to distinguish, is something along an axis. Much harder to distinguish is when we start to get into volumes. Here's my one plug and recommendation of a book if you want to learn more about visualization, technical aspects of visualization. There is a book by Dr. Tamara Munzner that walks step by step on good visual properties. Highly recommended. If you are a Tufts student or Tufts affiliated, you could access this book for free via the Tisch Library. It is quite technical because it comes from computer science. But I highly recommend, because each chapter of the book has a summary, like a little summary figure just like this. And so, for example, in this case, you will tell you that it's much easier to observe a position on a common scale. Like if we see coconut oil higher on the scale than butter, really immediate recognition. It gets harder and harder the more you move on the scale, when if we try to look at differences between volume sizes, is much difference to tell just for our eye.
We have a question in the chat. So What special management of visualization techniques we have to use to help blind people understand our graph, maps, or pictures?
So sometimes that I've seen actually in for people who have who may be blind or may have like a visual, I don't know, like someone who may need like specific glasses for it, or someone who may not have access to glasses to be able to see this better, is I've seen situations where you can have a written description of the graph. So it's not solely that you present the figure, but you have a recording that explains what are you observing. So you could start to narrate the forms, like the visual properties that you see there, to allow others to engage with your figure, especially if someone is engaging through a computer screen, or if someone is engaging through some sort of visual that doesn't allow like a tactile, like a touching of a screen necessarily. You could actually start to add the voice part of describing information for someone who may have like a visual impairment. One of the things I would mention about this figure, this type of recognition of how do we recognize attributes in the screen, is that more often, if you start to get involved into this world of data visualization, you'll hear more and more that pie charts are terrible. And if you use something like ggplot, for example, like the next workshop, ggplot makes it particularly difficult for you to create a pie chart. It's not an easy option. If you want to create a pie chart, you need to do a lot of coding to make it work. And that's on purpose, because the creators hate pie charts. They don't want you to create pie charts. And the reason for it is because they're really hard to distinguish. They don't have good visual properties. Because pie charts are actually more on this line of 2D differences. Like you need to find differences in areas. And if you have a 3D pie chart, that's just like horrible. Like don't even try to do a 3D pie chart. But you start to try to find differences based on areas and volumes, which are actually really difficult for our eye to see. So I'm actually going to show you why like some pie charts may be really tricky to use, but this gives you an idea of where some of that hatred for pie charts come from. So the key concepts of data visualization that we've talked about a little bit is the evidence, what are you showing, emphasis, who and why do you need this visualization, and efficiency, how do you construct it. So I want to keep this in mind as we look at some figures and some graphical displays. The first figure that I want to show you here is from the Georgia Department of Public Health, based on COVID data in their counties. The description that I have at the top, it came directly from their group. Now this figure has been taken down since, because there was a lot of controversy over it. So I encourage you to take a look at this figure, try to understand what's happening. So we have the top 5 counties in Georgia. And then this is supposed to be presenting COVID cases over time. And it's the most impacted counties. That's why there are only 3.
Tanya, as a slight aside, there is a question about whether there's specific data visualization platforms that you prefer to use, and if so, maybe could explain which ones you prefer to use.
I code everything in R just because that's what I learned, and it has a lot of flexibility. It's good for people who don't have strong coding backgrounds. So I don't code, for example, in Python or in other languages that require a little bit more knowledge of coding background. I could learn it, I just haven't made the effort to. And it gives me a lot of flexibility, but it does require, it's a little bit of a learning curve to get up to speed with it. But I code everything in R, and it's purely personal preference. I've been using more and more Tableau because it's really simple and it's really easy to create quick data visualizations. And I like the interactive dashboards that are a lot easier to put together than in something like R Shiny, which allows interactivity, but it requires a lot more coding. So I've been using Tableau. I've been using R. Sometimes I'll use Excel, to be honest, because sometimes you just need to like a really quick graph, and Excel is good for that. So I think it's solely based on personal preference. I find R to be great for my use.
Awesome. And in the interim, folks have been reviewing the visual, and they found that the cases are sorted from highest cases per time, but they keep the county colors, which is confusing, that they should keep the same order, and that the x-axis is not in any chronological order.
Right. So the x-axis, you start to notice, you start on April 28th, then it goes down to April 27th, then to April 29th, and it starts to jump all over the place. So when you show a time series, is convention to show it in the order of time, whether you're going, chronological order. One of the outcries and what there was controversy when Georgia Department of Health posted this picture, is because this gives you the impression that there is a declining trend in COVID cases. If you do not look at that axis carefully, you may see April 28th, really high number of cases. May 9th, low number of cases. Oh, in the past 15 days, they're actually not 15 days, there are 14 if you count, but this tells you 15 days. The past 14 days, according to this graph, cases have gone down. This is fantastic. We're doing a great job. If you take a look more carefully, it's actually not the case. I am not necessarily saying that this is something that was done on purpose, because it could have easily just been, for example, Tableau. You click a little icon on the side of the axis and it like sorts it immediately for you. So it could have been just user error where you just click an area and it like sorted it for you. Just the beauty of Tableau, but also the danger of Tableau, that it allows you to do really quick and easy things like that can lead to mistakes if you don't pay close attention. But one of the issues is that like it gives you this idea of a declining trend that is not really present and not really true. And as you notice, you can see that the color of the counties are at the top, but the bars are not consistent. Like they always show the highest bar first with the lowest bar coming down. So if you want to compare, for example, what has happened in Fulton County, it becomes really difficult to see because you need to start to trace where does the bar fall? Is it the first bar that I'm seeing? Is it the middle bar that I'm seeing? Where is that bar? So what I did is I took this data set, typed it in Excel, and created a figure in Excel. And I typed the new data set, which is available in the Georgia Department of Public Health website. And the first thing that I wanted to show you here is that data has changed. If you take a look at May 8th and May 9th, those records, I added this white line so it's easy to see where 50 and 100 is. You can see 50 here, there were like, 10 cases per day or something like that, right? Like it's pretty low. But if I take a look at the data set that has been posted now, we're more, closer to the 50-ish cases for some of these counties. And so why do the records change? That's where I recommend that you all think very carefully about the underlying records. What is the evidence? What am I actually showing? In this case, they're representing the number of confirmed COVID cases on this day. So if this report was issued on May 10th, it means that May 9th was incomplete. It means that May 8th was incomplete, because for these records to be complete, if someone publishes a report on May 10th, it means that any tests that were collected on the 9th needed to be the test had to be collected, it had to be processed by the lab had to give results, had to report the results back to the Department of Public Health. Public Health Department had to process those records and put them in this figure for you to be able to see it. All of that would have had to happen within 24 hours or less than 24 hours, depending on when the sample was collected. So all of these records, and you can see based on, it's really easy to see on the last two, the May 8th and May 9th, those are going to be a lot lower simply because the records were incomplete. So this is where there's some missing information because for two aspects. One, the records are not there and not available. And two, whoever created this figure should have made that very obvious that these records are incomplete. And you can see that a lot of the records changed. For example, here under Fulton, it showed that there were over 100 cases, but actually, if we take a look at April 29th, Now they're being reported as actually under 100. And that could be because some of the cases were potentially duplicates that were moved to a different date. So the records are constantly changing. You will see that some departments of health, when it comes to COVID, have opted, instead of reporting the cases on the date that they occur, they've reported the reported cases. So the cases when the test result came back. So it could be that the test result was test was collected a week ago, but they're started to report when the results came back. That's what it's being reported. There's a yes.
We have a question in the chat. So it says our new graph is still not in any chronological order. Was this on purpose?
Yes, it's on purpose because I wanted to show you how the records change. But I did fix the order in this graph when I actually changed the order in my next slide to actually show the chronological order, what this graph would look with the new data set in chronological order. And you see that spike right at the top. I still use the bars and I still use similar colors to what they're using. Difference is that now I'm keeping when the bar appears consistent, so Hall County shows up first in this set of bars consistently throughout the figure. I still don't think that this is a good figure. I still think it's quite difficult to see trends. So why not try a different type of figure? Why do we need bar charts? Why can't we simply use a line chart? And that's where a place like Excel or Tableau or any of this software makes it really easy for us to change the type of graph that we're showing. You don't need to stick to a bar chart just because that's the first thing that came to mind. You can actually create a version of the same graph, multiple different versions, and see what works best. This line chart allows me to follow a trend for each county a lot easier than a bar chart would. It's presenting the exact same information, but allows me to see trends easily, like a lot more easily than if I had that bar chart. So one of the recommendations that I have out of this workshop that I hope you take with you is to create lots of different figures for every single chart. Don't create one and think that you're done. Try different things. Think about what is it that you're trying to show. If you're trying to show trends, how trends change over time, first thing you should do, ensure that your scale is in chronological order. Second thing you should do to show trends is usually a trend. We tend to show it with a line. So start to think of lines rather than the bar charts. And then you can start to think of additional things. Do I need that, super dark blue background? Maybe, maybe not. We can think about it. Actually, if you go, I put the website here of the Georgia Department of Health. If you go to the Georgia Department of Health now, you'll see that this figure at the top has been replaced with a line chart. So whoever was designing these figures has changed how they report records. They're no longer reported just in 2-week increments. It's actually reported for the entire time series. So you just see the entire time series for these 5 counties still. But so these type of modifications have done there already. But that was in terms of access manipulation that I wanted to show you. And this is a figure that was posted in May. So these are not issues that occur in the past or that don't occur very often. They're extremely often when you have an access manipulation. The other graph I wanted to show you in terms of access manipulation is this graph of gun deaths in Florida. This was published by the Florida Department of Law Enforcement. And in terms of access manipulation, you can see right away that the way that they're presenting the access is quite different. It starts at 0 and then it increases to 200, 400, 600, and 800, but that is shown going down rather than going up as we're usually used to, where we start with a 0 at the bottom and start to have increasing numbers as you go up. This usually access modifications tend to distort the information that you're showing. So it's really careful to pay attention to these type of changes to understand why they're being done. And some of it is access manipulation. And so you have this like pattern that looks like it's going up and up and up until the 2005 law and then down.
Just sharing a comment in the chat says that it looks like a flag that was eaten by a rodent.
True. Little like niblets of a flag. There's also the color red, right, which is perhaps used on purpose because it's gun death, so a little bit of a gruesome graph. But then what happens if we just reverse the order and make it pretty standard, starting at 0, 200, 400, 600, and 800? It becomes more clear that there was actually a decreasing trend, more or less, with a deep and an increase right here up until 2005. And then after this law, you have a sharp increase in gun deaths. So the pattern that is being shown is quite different from one figure or another, simply based on how you chose to present your axis. Now, if you have a user that is really quickly engaging with this figure, and usually you should actually not assume that people are going to read your paper, read your news story, or read anything that you put together. Most people are going to want to engage immediately with your figure, take a look at your figure, draw their conclusions, move away. So if someone is interacting with this for, say, 10 seconds, the first thing that they notice is the colors. Then they start to notice, ooh, you put really bold white text here that catches my eye. There was a law. After the law, there appears to be a decrease. If you see the figure on the left, I'm moving on. So you shouldn't expect that people are going to take the time to pay careful attention to your axis. And that's where you can have some of this distortion, and that's where you can have data manipulation, even if it wasn't intended to do so, but the way your readers or your viewers are interacting with your figures could have that issue.
We have one quick question in the chat, Tanya. So how do you see infographics as a data visualization tool?
They're actually all over the place, and they're essential because they incorporate something like this, like a figure, but they'll have text that accompanies it. So it's almost like you're taking a paper or a report and you're trying to create a nice, usually one-page visual that includes text and words that guide the reader and the viewer through the story that you're trying to tell. So infographics use color heavily. They use figures heavily. So all of this applies to infographics. I have an example of an infographic lower down in this that I wanted to show you, and I'll show you, and I'll talk a little bit more about that in a sec. The other thing that I included here in terms of axis manipulation is this a figure I adapted from a paper where I'm a co-author, where you can start to think, forget about the data that's being shown here, but let's think about the graph. We have two figures. The scale goes in terms of temperature. A scale doesn't always have to start at 0. It can go from about 20 to about 40 in this case. And both of these figures at the top and the bottom have the same scale. They haven't moved. Now you could consider that, ooh, this is axis manipulation. Why am I not zooming into like the data? Suddenly, like that seems like there's no difference in these two lines. But in this graph, it actually didn't matter. Because if I zoom in and I try to zoom in and just expand that section, the overarching message of these graphs is that in panel B, there are no differences between the two lines. And when you see them, you'll notice that the two differences are very minor. There's a lot of overlap. And I was able to show that with this graph up here, the exact same thing. So in this case, whether I show the axis that is like farther apart or the axis that is farther, like wider, it didn't really make a difference. And in this specific paper, what we were looking is for temperature differences that were like, 5 degrees, or like at least 2 to 3, 4, 5 degrees, or maybe even 10 degrees hotter between the control and the air activated device and the exposure group. So this type of axis, whether I use wider axis, smaller axis, didn't make a difference. There's some places where it could make a difference. The other figure I wanted to show you is this map. One thing you should be really, really careful of is when you look at maps, you should think about whether you're seeing a map of population density, of actually a map of data. Because in this case, this figure tells us it's supposed to be the employed civilian population of people who are working in agriculture, forestry, fishing, hunting, and mining. In this figure, it's like, ooh, people in Texas, people in California, huge red dots. This also assumes, this type of maps also assume the centroid. So California, there's a centroid, is assuming that's where it's located. But if you have smaller states such as Massachusetts, Rhode Island, it can start to get busy if these circles were larger. could become harder and harder to see which state it belonged to.
Tanya, we have one question in the chat. So what's your suggestion for when to zoom in on your data point? My perspective is that this should be done only if your data is statistically significant.
I would say, for example, if I truly cared in this figure, if I cared about differences of 1 to 2 degrees, or if I wanted to show that there was a lot of data noise in this lower part of my graph, I would use my zoomed in graph. So I feel like there's a question, it's really hard to answer just in general terms. I think it depends on the data set that you're using, on what you're trying to show, and always ensuring that you're not distorting your data and that you're not manipulating your data. So my goal for this figure was, what I wanted to show is in part A, there is a temperature difference. In part B, we do not observe a temperature difference. Like that's kind of like the 2-sentence description of these figures. And so I can easily show that with part B. And I could easily show that with this zoomed in scale versus the other scale. And since there was no difference, like you're saying, there was no statistical difference, then there was no need for me to zoom in. Now there is, there was no difference in this case, but if there are places where you could observe a different trend if you zoom out, then I'll rather show the zoomed out version and then maybe have like a little inset where you pop out to the zoomed in version. So you could always use both if you think both are valuable, as long as you're making sure that you're not manipulating your audience necessarily to see a trend that is not there or to not see a trend that is there. So in terms of the graph, making sure that you're not seeing a graph of population density, because what if I change this figure to, rather than show just employed civilian population, I show employed civilian population where it's the percent of people who are working there rather than the absolute number. Suddenly, the more intense the colors with higher intensity, higher proportion of the population employed in forestry, fishing, hunting, mining, and agriculture tends to be like some of these states, like Wyoming, Montana, like some of these other states, and not Texas and not California. They're more actually on this lower range. But when I saw this map up above, California and Texas looked really, really big with the circles, but it's simply because they have really large populations that may be a lot bigger than the other states. So when you look at maps, it's always important to know whether they're showing a relative or an absolute number. If it's absolute numbers for a map, it may be simply related to the number of people that are there, which is in COVID cases, in the one in Georgia, when you're comparing states to states, you will often see that people would talk about cases per 100,000 people, not absolute cases, because it's really difficult to compare a state or a county that is heavily populated to one that is not. So that's when you start to have a ratio, or you have a denominator, you have a relative number rather than an absolute number. So some of the problems that we talked about today are distortion, ambiguity and confusion, or misleading information with that modification of the axis, missing information if you don't notify people that your data, for example, may be temporary, that is going to be changing over time, that is incomplete data set. In terms of data noise, it could be like different colors, it could be the use of the icons for example, the New York Times figure, if it gets too busy. And of course, something we didn't discuss, but that could be an issue too, is if figures are unnecessarily complex or too simple. So that's where the question comes in of why do you need a figure and who is your target audience? And we'll talk a little bit about especially the unnecessarily complex in one moment. So now best practices. We've critiqued some figures. Let's talk about, if you're going to build a figure, what should you do? What I recommend that you do. So best practices. First thing, consider the key concepts of graphical representation. E cubed, evidence, emphasis, efficiency. Who is the audience? Why are you creating this figure? What are you showing? How are you showing it? Avoid some of the problems that I showed. And as I mentioned before, avoid pie charts unless you have a very particular reason to use pie charts. So when we look at pie charts, this is one example of one of million websites that you can find that tell you why people hate pie charts, or why the blogger of that, the writer of this I don't know, perceptual challenge or whatever that is called, decided that is not good. And part of it is because, for example, for a pie chart, both of these graphs show the exact same information. It's showing you different companies and it's showing you the market share of those companies. The figure on the right has lots of colors, but lots of colors can often be distracting. And you start to notice, okay, I can tell that the, purple is the largest, but what about between the green and the red? I need to pay a little bit more close attention. What about between these two? It starts to become harder and harder to absorb this information quickly. The figure on the right presents the exact same thing, and it's really easy to see on a scale which one's smaller, which one's harder. There is the order in here is very clear, the largest, and then it starts to go down all the way to smallest. When you have a pie chart, there's inevitably the idea of a circle. And so it puts company F, which is this orange, next to company V with this, which is the purple. It gives you this idea of circularity, of continuity, which may not necessarily be true. Some places where we use this, similar to a pie chart, or for example, radar plots, but then you're specifically talking about calendar months. January, February, March, April, blah, 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 November, December, January again. So there's a continuity where you can go around and around in a circle, and there's a reason for it. Whether here, really putting company F and company E next to each other, or company B next to each other, it can be all really unnecessary, but in a bar chart, you can actually see the exact same information as in the bar chart a lot easily. You can see numbers very clearly, and you get more information with less noise. If you have 3 categories in pie charts, then they can be actually pretty decent to show information. If you start to have more than 3, it becomes really hard to tell differences. The other thing that I would say is to consider colors. What colors are you using? This is the figure I showed you in the beginning, which is it's a figure from, I think, the WHO on the nutrition decade from our report. And you can tell if you look at these colors that some of the colors are used all across this, what could be considered an infographic, actually, if they were trying to show some progress and some progression. What are they doing? When are they doing it? How are they doing it? But the color, especially if you're talking about targets, like the colors of the targets, I would expect them to be unique so that they're not confusing. At the top part on when, the colors seem to indicate when certain things are happening, right? Like you have a, darker orange towards, the 2025 line, but then darker orange farther down may mean that it's a target. So is it that that target is what's happening during that time? But then that target at the bottom also talks about different, how are you doing this? So the colors look pretty, but actually need to be meaningful when you use them. You need to understand why they're here together. Understanding what this figure means is actually really challenging because of the use of colors and because there's a lot of missing information. So really important to consider colors. The other thing I would say is create multiple graphs, as I mentioned, and share graphs with peers. So because I like to do what I recommend you to do, I'm going to show you the worst figure I've ever created. And here it is. It's absolutely terrible. It's 4 pie charts, not just one. And it's really difficult to understand what's happening. I have 6 different colors. I have 4 different categories. Knowing where to look, what information to gain from this figure is really challenging. I actually put this in a poster, and I talked to my advisor, and she told me, Elena Nomova, if you haven't met her, she actually told me, Tania, could I please use this as an example of what not to do? And I think it's true. This is an example of where you absolutely should not do. But what did I do with this information? I took it, I adapted, I created a new figure and a new figure and a new figure, and I probably created like 10 different versions of this figure. And through that iteration process and through showing it to peers and to my advisor, I came out with the realization that this is overly complex. I do not need this much information. A lot of this information is not important. This is the figure that ended up making it on the paper. 2 colors, not 6 anymore. A lot more information because now I have actually some p-values, tells you a little bit more about statistical differences. I only care about whether there was deterioration or no deterioration in the water quality. So it's a lot easier to consume. And I realize I do not need 6 categories. 2 is plenty. And I don't need that additional information. I don't need 4 pie charts. Actually, this stacked bar chart was plenty and was sufficient for me to convey my message. So sharing with peers, creating multiple versions of the image, I highly recommend. If I were doing this now, would I change some of how this figure is created? Absolutely. It's really hard to think of like, great, I'm done, it's perfect. Like I would still make some modifications, potentially think about color, potentially think about the descriptions, but that's just inevitable to continue to make changes. And the other thing I would say, text. Think about the text that you're including. So this is part of an infographic that I put apart. And so when someone asks about infographics tend to have this type of visuals around them, but there's also text that goes with those infographics. And thinking about the text is extremely important because this infographic was designed by Flaming Toast Productions in Princeton, at Princeton University. Talked about the fries that bind us. So it was talking about McDonald's having a certain number of restaurants in these many countries, and it's talking about fries. But then all of a sudden down here, you have Starbucks, and Starbucks doesn't sell fries. So then how does the text relate to that? But then you also have the GDP of Afghanistan in the middle of this. Like, why is Afghanistan being brought into this mixture? Is right, like maybe you'd look at this and you're like, okay, the colors, the red and the yellow, like that brings us to McDonald's, that gives us to like fast food, but then there's a lot of different elements that don't make sense. So when you think about infographics, the same questions apply. What are you showing? Why are you showing it? Who's the audience? How are you making the visualizations effective? Why do you need to show the GDP of Afghanistan? That may not be the same thing. Maybe you want to compare and say that the GDP is actually a lot higher than the GDP of some countries. You could potentially say that in a different graph with different text, not necessarily in a way that's confusing, that is not addressed anywhere else. So that is it.
Thank you, Tanya. We actually have one question that came in, and for those who have other questions, please post it in the chat. So what platform would be the best to create infographics?
Okay, so I haven't created infographics, so I do not know if there are specific platforms for you to create infographics. I have created dashboards, which sometimes can resemble infographics because you have information, you have figures, you have a story that you're telling, and I've used for that Tableau. Other times when I've had to present information in more poster style, infographic style, I've just created my figures in R and copied and pasted it into like Publisher or PowerPoint. So I unfortunately am not the best to answer about best software to create infographics.
Yeah, and just looking back at a comment that Ryan has responded earlier, that maybe trying PowerPoint or Publisher, they have a lot of flexibility to incorporating text and figures. I'm not sure if that answers your question, Lucia. And
yes, thank you.
Thank you. We also have a comment saying that this workshop is very helpful, and the main take-home message is to not use pie charts ever. And thank you for the presentation.
Okay, so caveat to all this. I was co-author in a paper on greenhouse gas emissions of corn ethanol. And we actually include a version of a pie chart in there, but we included it because we needed a graphical abstract. And so the goal of that was to show which are the main contributors to the central number. So we made it into like this design feature that has like circles and things like that, but it's mainly because we didn't expect people to truly engage with that. We'd expected people to read the paper. So caveat, I wouldn't say never do something, always do something. Make sure that it fits your needs.
Thank you. And I think we have a couple of minutes left for questions. So please post any questions you have in the chat. And Here's one comment about Stephanie Evergreen's DataViz website. It says it shares a similar ideas as presented today and is a great resource. So that's for those who are looking for resources out there.
Thank you so much for sharing it. I had not engaged with this website with Stephanie Green, but I'm excited to take a look at it. Thank you.
Another question, do you have thoughts on graphs with 2 axes? Is it recommended?
As long as you can show very clearly which line connects with which axis. So sometimes when I've seen it used the most effectively is when you're trying to show similar trends between two data sets. For example, if you're looking at flu, let's say cases of flu compared to temperature. And so you can start to see trends in one versus trends in the other. What I would make sure is that the 2 axes are aligned so that you can actually read them carefully. And that is very, very clear which line belongs to which area. So I would recommend 2 axes when the patterns are clear and when the patterns are clear. They're software like ggplot that makes it actually hard to use 2 axes. So again, ggplot is a software that's very opinionated. I actually love it, but very opinionated in terms of what you should and shouldn't do. So double axis, dual axis on ggplot is actually quite hard. And it's because their creators consider it to be really difficult to properly create those and to have an audience who can engage with those visuals. So I would recommend it more for actually a paper rather than anything else. And I just see the figure, like what do you do when there are different scales? Oftentimes you try to have a multiplier. So if one scale is, if you can multiply it by like 10, so then at least you can align like the lines, the tick marks should be at least like the line across the axis should line number to number. So in one side, you can have a number that is 100, and then the other, you could have a number that is 250. But as long as they align and that the spacing between them is consistent. So that's where it becomes tricky to create them, because you need to think about how do you align your scales? How do you align your axes? So I've seen them used effectively in journals. I haven't seen them as much in, for example, newspaper articles or reports. It tends to be a little bit harder to make sure that you are giving the message clearly that you want to give.
I would like to thank Tania for a wonderful presentation, and thank you all for joining us today.